Hello guys, welcome back to the Universe of Tech Up. In this tutorial, we will learn about what is Quicksort and how it is works and why it is used, what are the applications of Quicksort and real life examples also, and how the algorithm works. First, what I need to do is, first we need to understand what is Quicksort. The Quicksort is a highly efficient and widely used sorting algorithm that employs a divide and conquer strategy to sort elements in an array or a list. It means quicksort is works by selecting a pivot element and partitioning the array around this pivot element so that elements is smaller than the pivot are on its left and elements larger than the pivot are on its right. It then recursively sorts these partitions. It works by selecting a pivot element from the array and partitioning the other elements into two subarrays, those less than the pivot and those greater than the pivot. The subarrays are then sorted recursively. This is what is quicksort. Next, why it is used. Why quicksort used? The purpose of quicksort is it is efficiently sort an array or a list. Quicksort is generally performs better than other sorting algorithm. It's faster than the other sorting algorithms like bubble sort or insertion sort, especially for a large data sets. It requires small, constant amount of additional storage space, so that we need to use a quick sort. Next, we move on to the how it works. First, we need to choose a pivot element. Pick an element as the pivot. It can be first element or last element or middle element. Next, we need to partition an array. Rearrange the element so all the values is less than the pivot are on the left side and all the values is greater than the pivot are on the right side. Then we need to recursively sorting. Recursively apply the same steps to the subarrays on each side of the pivot. Combine after sorting both partitions, the array is fully sorted. Finally, we get the fully sorted array. Next, what are the applications of Quicksort? Quicksort is used for the sorting in arrays or lists in various applications, including a database and search engine like that. Next, we need to use it in the data analytics to sort a large data sets efficiently. And also used in many programming languages use a quicksort or its variation as the default sorting algorithm in their standard libraries. The quicksort is data when accessing the records, pre-sorts for binary search or other search-based algorithm. I'm taking real-life examples. It's used in the quick sorting of gaming leaderboards and also used for sorting product by relevance, price or ratings like that. We need to use the quick sort. I need to take another real life examples to how quick sort works. Like sorting a customer orders in e-commerce platform receives a multiple customer orders that needs to be processed in a specific order, by date, order date, or total amount like that. When the orders are sorted in a database, quick sort can be used to sort them by date or total amount quickly. This allows the systems to efficiently fulfill the orders based on urgency or value. It's improving the operational efficiency. This is how quicksort works. Next, we move on to the algorithm. Quicksort. Here is an how quicksort works. This is the step-by-step process. First, we need to choose a pivot. Pick an element as the pivot. It can be first, last, middle, or random element. It serves as the pivot. Common strategies include choosing the first element, the last element, and random element are the middle. Next, we need to rearrange the array so that the elements is less than the pivot come before it, and elements are greater than the pivot come after it. The pivot is now in its final position. Next, we need to recursively apply the above steps to the subarray of the elements with smaller values and elements with larger values. Next, we need to The recursion ends when the size of the array is 0 or one such an array is already sorted. After sorting both partitions, the array is fully sorted. This is the algorithm how quicksort works. This is the visualization of quicksort. How quicksort works. I need to take element as 10, 7, 8, 9 and 1, 2. This shows how quicksort elements. This is how quicksort works. This is all about quicksort visualization. Hope you guys understood. We pick 40 as a pivot element and initialize I is equal to -1 to mark the boundary of the smaller than the pivot elements. Next, I need to compare j with pivot. First, I need to compare j with pivot element. The 10 is less than pivot. 10 is less than pivot. Pivot means 40. The pivot element is 40, right? 10 is less than pivot. Yes. We need to increment I. Now, we need to increment I. I is equals to now 0. After -1, I becomes 1, right? 0, right? Now I becomes 0th index. It means 10. Next, I need to swap with 0, I and j. The I is 10, right? The j is also 10. We need to swap. Then again I also getting a 10. So no need to do this. 10 with 10 is 10. That's it. Next, I need to go to the next element, that is j. Now j become 1. Now j become 1, right? Now j become 1. Again I also compare with j. Now j becomes 1. In index 1, we need to store the values as 80. Compare with 80. 80 is less than 40. No. No swap needed. Just increment the j value because j traverses all the elements up to pivot element. So increment j. Now j becomes 2. Now j becomes 2. What I need to do is compare 30 with pivot element. The 30 with pivot. 30 is greater than 40. No. 30 is less than 40. Yes, right? 30 is less than 40. Yes. We need to increment I is equals I. We need to increment I. I becomes 1. Next, I need to swap with ith value and jth value. Jth element. In j element, next 30 is less than 40. Yes. We need to swap I and j. 80 with 30. We need to swap this. Now, arrays look like T and 80. Next, increment j. Now, j become 3. J become 3. We need to compare 90 with 40. 90 is less than 40? No. 90 is greater than 40? Yes. We need to increment j. No need to do this. No swap needed in this. Increment j by next element. The next element is pivot. Now j traverses all the elements. Since traversal of j has ended, now move to the pivot. It's correct. Move the pivot to its correct position. Now move to pivot elements to its correct position. This is the pivot element, right? Swap. First, we need to increase I. I plus 1. We need to make I plus 1. I is equal to 1. Already I is equal to 1. Now we need to add another 1. 1 plus 1 is equal to 2. So now array I is equal to 2. I is equals to 2 means 80. Now we swap 80 with 40. Now we swap 80 and 40. 80 place 40 is placed. In 40 place 80 will be placed. Pivot elements is find the correct position. This is the pivot element correct position. Next, what we need to do is we need to divide the two sublist. Partitions the two list pivot element, right? Partitions the list into two sublist. In two sublist and 30. Left sublist. This is the right sublist, right? We see that in left sublist contain smaller elements, in right sublist contain a greater element compared to pivot element. This is the pivot element. Now this is the 0th index, this is the 1 index. Same, I need to sort side. This is the pivot. To compare j value, 10 is less than 30. Yes, no changes means no swap are needed. Now 30 is in its correct position. The left side is divided into the left single elements like sublist. The left subelement, the left sublist is 10. The right sublist is empty. No sorting is needed. Now next we move on to the right sublist. This has the pivot element. This has the j. What I need to do is we compare the j with pivot element. 90 is less than 80? No, right? Or 90 is greater than 80? Yes. 90 is greater than 80? Yes. 90 is less than 80? No. So, what I need to do is to swap. To swap with I and pivot element. 80, right? 90, right? We get 80 and after swapping 80 and 90. Now 80 is in its correct position. The right sublist is divided into the left sublist is empty, right? The left sublist is empty. The right sublist is contain a 90. It is already sorted. Combine listers. We need to get 30. 40 is the pivot element. It is already sorted. It's already in its correct position also. All elements are in its correct position. We need to get the all elements in ascending order. Now 80 and last one is 90. 90. The last one is 90. Sort algorithm works. Recursive sorting. I am taking another example. In generally we take last element as pivot element. This is the last element, right? This is the pivot element. I represent P. It means pivot element. This is the jth element. In previous class, in previous tell why I is minus 1 because of the I is less than the pivot element. So I need to take I is equals to minus 1. Now j is the 0. First, I need to compare j with pivot element. We need to increment j by 1. No need to do. Now j become 1. Now j become 1. Next, we need to compare 3 with 2. 3 is greater than 2? Yes. 3 is greater than 2. So, No need to swap because 3 is greater than 2. So increment j as 2. So increment j as 2. Now we need to compare one is less than 2. Yes, we need to 1 is less than 2. Yes, we need to increment I is equals to 0. We need to increment 1. It means I is equals to 0. Then we need to swap 1 and next we need to swap 1 and 8. In place of 8, we need to put 1. In place of 1, we need to put 8. Next, increment j. Now j is 3. So we need to compare 7 with 2. 7 is less than 2? No. So what I need to do is just increment j. No need to swap because j is greater than 2. Now j become 3. Now j become 4. Now j become 4. 0 is less than 2? Yes. We need to compare it. 0 is less than 2? Yes. Less than or equal to 2? Yes. So we need to increment I as 1. We need to increment I as 1. Next we need to swap 3 and 0. 0 is put it on to the 3 place. 0 plus 3 is putting 3. So next increment j. So next increment j. J as 5. 10 is less than 2? No. 10 is greater than 2? Yes. So no need to do is now the traversal of j is ended. The last element 2 is right. Now j is traverse 1, 0, 8, 7, 3 and 10. Now next we need to place pivot element to its correct position. 2 is the pivot elements, right? Just we need to increment I plus 1. The I value is already 1. Plus 1 means 2. Now I becomes 2. I become 2. We need to swap with pivot element. Position we need to put 2. Pivot position I need to put 8. After this we need to get 1, 0, 2, 7, 3, 10 and 8. Next we move on to the recursive sorting. First what we need to do is we need to divide the array into the 2 sublist. This is the pivot element, right? So we need to divide the list into the sublist. In sublist, left sublist consists of 1 and 0. In right sublist consists of 7, 3, 10 and 8. 7, 3, 10 and 8. 7, 3, 10 and 8. So first we need to sort a left sublist. This is the 0. This is the pivot element. This is the pivot element. The j is equals to compare j with 1. 1 is less than 0. Yes. Less than 0. So 1 is greater than 0. Yes. We need to swap. After swapping, we need to get 0 and 1. So no need to do this. The left sublist is contains a 0 and right sublist is contain empty in the left recursive. Next we move on to the right recursive. 0, 1, 2 and 3. Now I take a 8 as the pivot element. is equals to 0. It means 7. Compare J with pivot element. 7 is less than 8. Yes, 7 is less than 8. What we need to do is increment I. I is equals to 0. Then swap with I and J. The I is also 0 and J is also 0. 7 swap with 7. We need to get 7 also. So no need to do any changes. Next, increment J as 1. Next, this is the J. Compare J with pivot element. Now J is 3. 3 is less than 8. Yes. So what we need to do is, no need to just increment I becomes 1. Now I becomes 1 means I becomes 3. I and J. Now J is also 3 and I is also 3. No need to do. The 3 is swap with 3 is 3. Again we get 3. So we need to increment J. Now J as 10. Now J as 10. This is J. Need to compare J with pivot element. Again need to compare. Is less than 8? No. 10 is greater than 8? Yes. So what I need to do is, now 10 is greater than 8. So what we need to do is increment J. Now J as ND traverse. We need to do pivot element as its correct position. Now swap with, it means I is equals to 3. Now I plus 1 is 2. So this in second position 10. We need to swap with 10 and 8. In 10 position we need to put 8. In pivot position we need to put 10. So this sorting is completed. 8 is pivot element, right? This is again I need to divide list sublist. 10, 7 and 3. 10, 7 and 3. The right sublist contain 10. Only one single element. So it's already sorted now. This as J and the last one is pivot. I need to compare with J with pivot element. 7 is greater than 3. Yes. What we need to do is swap with J and pivot elements. Swap with J and pivot. So what we get is 3 and 7. 3 and 7. Left sublist. This is the pivot element. The right sublist is empty now. Next we move on to the right sublist. It's already sorted and it is also contain a one single element. So no need to do this. We need to combine these sublist into a single sublist, single list, fix sort in ascending order. This is how fix sort we do. This is all about the fix sorting. If you like this video, please don't forget to subscribe, like and share and comment in this video.